Could you imagine how the life of a blind person could be? They must use cane all the time and it is not effective enough. Or they can navigate with another person. But what if their life become easier? The idea of our project is smart glasses work as the human eyes, which recognize objects, and measure the distance between the blind person and each object in front of him. Then read the results with a human voice through headphone. And now, we are going to present each step with explanations and results. In calibration, we capture 40 images or more, with different angles using chessboard. There are two types of calibration. First type is calibration in real time as the left part of the video. And the second is calibration from saved images as the right part of the video. This is the only phase in our project which can be executed once, if the result is good. The outputs of this phase are two files with YML extensions which can be used in other steps. The two files contains the camera parameters in a mathematical way. Extrinsic file includes measurements about the two cameras like the position and the orientation. Intrinsic file includes measurements about the images like focal length, baseline, lens distortion and image sensor format. So, why do we use chessboard? There are two main reasons. First, chessboard is a difficult geometric shape, consists of the same pattern repeated many times. 50% of them are black, and the other 50% are white, so if corners detected correctly, then ambiguity is removed. Second, chessboard detection is already implemented in openCV so you can use it easily. Rectification phase has two main parts. Step 1, removing the lens distortion according to the parameters from the calibration phase. Step 2, alignment of the two images position, where every point in the left image is on the same line of the right image. Using the green lines appears on the screen which is called epipolar lines. In correspondence, we work on the aligned images from the rectification phase. The output of this step is disparity map, which contains the difference between the x values for each point in the two images, represented by grays between white and black. The difference in y is not calculated, because the two cameras are placed on the same y position. In all previous steps we were dealing with 2D image, but now we are going to deal with 3D points, by calculating the Z dimension for each point in the image. Z value is different according to each object in the image. The output is depth map, which represents different values of Z. In previous 4 steps, we were talking about the first way of our project which is called stereo vision system, in order to get 3D points. First step in the second way is segmentation. Now we are going to deal with 2D image again. Objects are separated from the background and separated from each other. Green frames are put on each object, to make recognition and distance measurement more easily. In recognition, we will use the result from the segmentation phase. Features will be extracted from each object using surf algorithm. Then comparing the features with the training set to get the closest matching of each object. Classification is done using support vector machine. All previous steps done internally. The actual output is voice that alerts the blind person, and tell him information about objects in front of him, and the distance between him and each object.
Bottle on 0.94 meter. Box on 0.78 meter. Statue on 0.68 meter. Bottle on 0.75 meter. Box on 0.79 meter. Statue on 0.68 meter.